In this video, we will be building end-to-end data engineering project using Python, Spark, and Databricks in transportation domain. On this channel, we have published bunch of Databricks videos previously where we have covered Databricks foundations. We also created end-to-end project in FMCG domain. The goal of this video is to build this project using Lakeflow Spark Declarative Pipelines, also known as SDP. SDP is a declarative framework which differs significantly from traditional procedural way. We will be doing all of these using Databricks free edition account. Yes, you don't have to even give your credit card details to sign up. This free edition enables students and practitioners to learn professional data and AI tools for free. As per the official documentation, Lakeflow Spark Declarative Pipeline is a framework that allows you to create batch and streaming data pipelines using SQL and Python. It offers three primary benefits: automatic orchestration, declarative processing, and incremental processing. Now I understand this may sound like jargons to you, but don't worry, I will explain all these concepts in detail using simple and intuitive language. We will learn all these theoretical fundamentals while building the project, okay? So let's straight away jump into the problem statement for our project. GoodCab is a fast-growing cab service company operating across multiple cities and regions. As the business scales, regional teams increasingly depend on timely region-specific data to run daily operations. During a routine regional review, a serious concern emerges. Regional managers are not receiving data on time, and the dashboards they get are generic and hard to use. Teams are forced to export data and manually rework it for their regions. Bruce Haryali, responsible for platform outcomes, realizes this feedback is coming from multiple regions. This is no longer a local issue, it is a systematic data platform problem. Bruce calls a review with the data team. He expresses clear dissatisfaction. Data is late, views are inefficient, and innovation has slowed. From his perspective, stability alone is no longer enough. Tony Sharma explains the current state. The platform relies on procedural Spark pipelines with manual orchestration. While stable, these pipelines are tightly coupled and slow to adapt to regional needs. For Peter Pandey, this feedback cuts deeper. This is not just a project failure. It is a matter of his team's credibility and respect. Peter is determined to prove that the data team can innovate and deliver at scale. Peter proposes a bold shift, using Databricks with Lakeflow Spark Declarative Pipelines. Instead of manually orchestrating every step, the team will declare data intent and let Spark handle optimizing execution plans, manage dependencies, and handle incremental processing at scale. Tony, though cautious, supports Peter and entrusts him with leading the pilot. Bruce remains unconvinced. He gives the team a clear ultimatum: prove that this new approach can deliver fast, regional insights, or the platform direction will change. With the stakes set, the project begins. In this journey, you will join Tony, Bruce, and Peter as they explore how Lakeflow Spark Declarative Pipelines can transform regional analytics together.
Hey Peter, you saw Bruce's email, right?
Yeah, I saw it. Not exactly the great way to start the day.
Yeah, I mean, the real problem is we can't even convince him technically. We can't go into the technical depths. It will really bore him.
Yeah, it will make the problem worse.
Yeah. So what I want to do is, right, I want to do something very simple. And I want to give something what Bruce looks like as a solution, which is he wants the regional managers to get the data faster, number one. And at the same time, it should really look something innovative, because what Bruce really thinks is that we are not doing anything innovative.
Got it. We can do something that's game changing.
No, Peter, let's not spend a lot of time on this. I want this to be rather quicker. So go for something that's a quick win, that looks innovative, and at the same time, it provides a solution. Okay?
So more like an experiment?
Exactly. Right now, it feels more like a trust issue than a tech issue. So we need to restore that trust with Bruce by doing something that reduces the manual work, increases the speed, and especially the regional team should stop complaining.
Okay, I think I have something in mind. Instead of redesigning everything, why don't we try a declarative approach where we focus on what to do rather than how to do it?
Okay, so when you say declarative, did you mean Lakeflow Spark Declarative Pipelines? I've read about it somewhere. It's a new feature from Databricks.
Yeah, exactly that. We'll do just one focused experiment to see if it helps.
That sounds good because I can see that Databricks is putting a lot of money on stuff. They are raising billions of dollars, and I'm pretty sure they must be doing a good job on this. Yeah, I think let's go ahead. I hope this will be something concrete for Bruce.
Sounds good. I will start working on it right away.
Great.
I hope you already got the idea on the problem statement for our project based on the introduction video as well as the stakeholder discussion. But let me add few more details. GoodCabs is a company similar to Uber and they operate in all these cities in India. Now city is a dimension table. We are going to use this city.csv file in our project. And as you can see, they operate in Jaipur, Surat, Kochi, etc. and these are the city IDs. They also have trips data and each of these record represents one trip. So for this trip ID, the fare amount was 337. This was a passenger rating and driver rating. Distance traveled was 25 and so on. Okay, so they have all these cities which are the regions and this is the trips data. This is our fact table. This is our dimension table, and the management of this company wants to know what is the average customer rating per city, what are the total number of rides, and what is the total revenue. They also want to know the region wise analytics. This is their main area of interest, and when I say region, each of these cities are regions basically. So let's say there is a region manager or a city manager who is handling, let's say, city of Surat. They want to know, okay, how the analytics look like. Okay, what is my average passenger rating, driver rating, what is my total revenue in that particular city, and so on. Now in terms of technical architecture, we will use obviously Databricks with Lakeflow Spark Declarative Pipelines, and the way it will work is we will provide you CSV files which we are going to upload it into Amazon S3. Okay, so S3 bucket. In a real life, what will happen is you will have Uber like app on your phone, and this app data gets aggregated into some relational database. It can be Oracle or whatever, and then from there you will do data extraction and you will store data in S3. Okay, in our case, we will just give you CSV files which you can upload to S3, and from there we will ingest data into Databricks. We are using Medallion architecture where we will process data through bronze, silver and gold layers. We'll be using declarative pipelines, and you will see the magic of this declarative pipelines as we implement the project. We will use Unity Catalog for access management, and we will do some analytics using the AI feature. We are not going to worry about building dashboards because that's not the intention behind this project. Now, if you don't know Databricks foundations, then folks, we have another video where we have covered the foundations. All right, so let's begin the implementation work. Let's go ahead and create an account in Databricks. All you have to do is click a link down below in the video description and you will come here. This is Databricks free edition. They have created this free edition so that learning community can benefit, and we truly appreciate that effort. Setting it up is very easy. I'm going to use my Google account. You can use your email ID as well. So click on continue with Google and I will select my Google account, say continue. And here for personal use, get free edition, click on continue and start the puzzle. Okay, so I think this is the right answer. Hit submit. After a few seconds, my account is ready. I am in Databricks environment right now, and the first step we are going to perform here is setting up our catalog and schemas. What we will do is go to workspace, okay, here, and create a directory to store our code, and we will call it, let's say, project transportation, or let's say GoodCabs, right, whatever. And here we are going to create a new notebook that will help us create the catalogs. Okay, so let me open these catalogs in a new tab, and as you can see, I have few catalogs: workspace, system, e-commerce, and so on. and we will create a catalog for our transportation project. Now I have already created this project setup Python notebook. So instead of writing code from scratch, we can just drag and drop this file here. By the way, you will find all the code in the video description below. Okay, so let's just import it. And here we will connect to the serverless session. So just click on it. And the first line here is taking the catalog name. So let's say Control Enter. We are creating a widget here. So let's say if you want to change the name of the catalog, you can change it here. And by using this function, it will get that name there. Okay. So let's say when you print this name right here, whatever you have given in the widget, it will take it. Widgets are useful, especially for cases like you want to use a different name for catalog, you want to have same code running for different environments, dev, prod, beta, etc. In that case, these widgets are pretty useful. Now let's create a catalog, and the way you do that is by running a SQL query, create catalog if not exist. Okay, so when you Control Enter, it will create it. All right, this is done. Now if you go here and refresh, you will see this transportation catalog. Let's create schemas underneath. So we are going to have bronze, silver, and gold schemas following our medallion architecture. Let's hit Control Enter. Schemas are created. So when you hit refresh icon, you will see these schemas. Now obviously these schemas don't have anything in it, and don't worry, we will create our data sources in these schemas as we move forward in this project. Next step in the process is to set up the S3 bucket for our dataset. As you can see in the architecture diagram, the trip data is generated by a mobile app, and the data goes to some OLTP database from where we are running data extraction script. And eventually data will land into this S3 bucket. Okay. Now, obviously this is a data engineering project and we are not focusing too much on OLTP. So what we are doing is I'm going to give you a bunch of CSV files, which you and I both we will upload to this S3 bucket, and we will implement the project from this point onwards. Okay. So let's log into the S3 account. I hope you all have a S3 account. And here you can either type S3, or if you have used it already, it will show it on your home page. And we are going to create a new bucket. Okay. So let's call this bucket Good Caps. That's the name of the company. And the bucket has to be globally unique. So many of you are watching this video, and if you start using the same bucket name, it's not going to work. It has to be globally unique. So to make it globally unique, what I'm doing is I am appending some suffix. Okay. So I'm just saying DP1, Dhaval Patel 1. Similarly, you should use your name 123, right? If you are Maitre Mishra, for example, you can say MM1. If you are Robert John, RJ12, whatever. Make it unique. Okay. That's a common sense, folks. And then let's create a bucket. Everything else is just default. The bucket is now created. Here, I will create a folder called data store. Okay. So let's create this folder, create folder, pretty straightforward. In this, I will create two subfolders for city and trips. Now see, if you look at the data set that we have given to you, we have city and trips, two folders. Okay. So let's do that. So create a folder, call it city, pretty straightforward. Another folder at the same level. Okay. And call it trips, create folder. See, now you have city and trips, right? So in city, you will drop just one file. We have only one file with few cities that we are going to drop it here. Okay. So drag and drop. Yes. So this is the files and folder. You can say upload. Okay. Now see, I'm in city and I already see this city.csv file. Let's go to trips, and in trips, we are going to upload all the data from full load. So see, we have daily files coming in. Okay. August 1st, 2nd, and so on. We'll just select all these files. Okay. And let me click on upload. Select all these files, left mouse click, drag and drop. So let's upload all these files. And it is some data, so it's gonna take some time. So let's wait. While my files are being uploaded, in parallel, I can establish a connection from Databricks to S3. And if you have seen my previous Databricks video, we have already done it. Okay, so the process is straightforward. What you do is you click on this menu, go to catalog and click on external data. Okay, and here create an external location. Okay, next, and the bucket name is S3 good cabs DP1, right? That's my bucket name. For you it will be different. Generate a new token, copy this token, click on launch in quick start, and make sure in the same tab you are logged in into your S3. And here Databricks personal access token. Okay, copy paste that. Okay, I think this is all same. I acknowledge, create stack, and it is saying create in progress. It is going to take some time, folks. So let's wait for a few minutes. After a few minutes, this is complete now. And when I go to now Catalog Explorer and click on external data, I will see that connection. Now you click on it, go to browse. You are seeing this directory, data store, which has sit-in trips. Trips has all these files. This means the connection is set up. Now Databricks will be able to pull files from S3. We will be using Lakeflow Spark Declarative Pipelines for this project. And for that, we need to understand declarative programming. Declarative programming is a programming paradigm. It is not restricted to Databricks. There are many programming languages and approaches that supports declarative programming. The opposite of declarative is imperative. So let's understand it by going over a very simple example. Let's say you have this Python code which will filter those users who has age greater than 21. You are running a simple Python loop and aggregating your results into this result array. Now if you're using SQL, the same thing you can do by running this SQL query. Okay, so assume you have database with all the records and you want to filter those who has age greater than 21. In that case, you can write this SQL query. So this SQL query is declarative and this Python code is imperative. In imperative coding, you focus on how to do it with great details. I want to filter records greater than 21 age, and I will give all the details. Okay, run this for loop, check if condition, append result to this particular array. Whereas in declarative, you focus on what to do, then how to do. Okay, look at these two examples, you will get an idea. So for our project, we will use the declarative, this kind of approach where we will focus on what to do rather than how to do it. Now we are going to work on processing the data in our bronze layer, and we will start with this city table. The file is pretty simple here. You have city ID and city name. So what we will do is we have this data in S3, correct? See, we have it in S3 and we will ingest this in our bronze layer. Now, if we were doing imperative programming, which is opposite to declarative programming, what we would have done is we would go to workspace. We will create a new notebook and we will write a code that will look something like this, where we will have S3 bucket as your source path. Your table name will be transportation.bronze.city. If you look at the catalog here, you can see transportation, which has bronze table. So you'll create a new table in bronze called city. And then you will have a Spark data frame, which will read the CSV file from this source path, which is your S3 bucket. Okay. And we have done this kind of coding before in our Databricks Foundation video. So once again, you can refer to that video. Okay. I'm not going to explain everything in detail because we have covered that. And then the step number 2 will be to add some metadata columns. Okay, we do it for the purpose of audit, for the purpose of debugging issues. It is important to add this kind of metadata column, which is file name and ingest date time. And then since this is a bronze layer, we are not doing any transformation, etc. We are writing the data as is with metadata columns into the bronze delta table. So you'll say df.write in delta format and target table, and target table will be transportation.bronze.city. And then you might set some properties such as enabling change, data feed, CDF, and couple of other parameters. Okay, so we can just copy this code into Jupyter Notebook, run it, and it will work. But that will be imperative programming. Imperative programming tells you how to do things in detail. But here in this project, we are using declarative programming. We want to focus on what to do rather than how to do it. Lakeflow Spark Declarative Pipelines, which is SDP, makes this thing super easy for us. So here I will click on jobs and pipelines. I will show you how to create the declarative pipeline. You can click on this ETL pipeline. Okay, so let's click on it. And let's give it a name. We will call it transportation pipeline. And here we will select the workspace. So let's select the transportation, which is your catalog. Then select the schema, which is bronze, and Lakeflow pipeline editor on. Okay, so this here through this editor you can build your pipeline. We are going to start with an empty file. Okay, so let's click on this, and here you will select your project directory, which is your project_transportation. So let's hit select. All right, so see, I will explain this UI components. On the left hand side, what you see is the code that your declarative pipeline will run. And by default, it will have this transformations directory, which has this default file. Okay, so this file contains nothing right now. So what I'm going to do is here, I will add some subfolders. So let's create a folder for bronze. Okay, so now I have a folder for bronze processing, another one for silver. So the code for bronze, silver, and gold processing, I want to keep it in a different folder, and then gold. Okay, and this file we can move it to bronze, and let's rename this to city. So let's click on rename, call it city.py. Okay, and here, see, this is the editor for city.py. So you will write the actual code here, and on the right hand side, what you see is the pipeline graph. So as you build your pipeline, as you run it, either you can run it or dry run it. I will explain what dry run means. You will see this graph being built up. Okay, so for city, what we are doing is, let me just write a simple function, simple Python function, where we are reading the data from source path. So what is my source path? Okay, let's see. Source path is nothing but the path of your S3. Okay, and in our case, in my case, it is good caps dp1. In your case, it will be your bucket name /data store /city, right? So see, if you copy this and if you say, see, this is what we have essentially. Okay, so let me just to confirm. And then I have a function. Function says that load this S3, whatever files are there in this S3 bucket, load them into a data frame. And I'm supplying a couple of options. So it's a CSV file, header is true, infer schema is true. Mode permissive means, let's say in my CSV file, one of the records is corrupt. It is not adhering to that CSV format. In that case, permissive means just allow it. The other option is fail fast. Okay, the other option, let's say if you do fail fast, it will actually crash. The moment it encounters a bad record, it will crash it. But we don't want to do that. We are being tolerant, okay, and we want to allow bad record. But what happens to that bad record exactly is specified in this. So you will have a column called _corrupt_record. And if the record is corrupt, you will take that entire record as a string and put it in this particular column. And the other columns, you will keep it as null. Okay, so that is how you handle bad data. And then you want to add the metadata columns, right? So if you look at our imperative code, we essentially added these two columns. So that's exactly what we are doing here. Okay. Now you will return this data frame. So essentially you wrote a function which reads data from S3. It adds two metadata column and it returns it. Now you are wondering like, okay, what's going on? Or who calls this function? Well, that's the beauty of Lakeflow Spark Declarative Pipelines. It will call this function directly, but it will not call it yet because we don't have the decorator that we need in order to call this. So let me put this decorator. You might be aware about Python decorators, right? Let's say if you want to time the function, you can say time it something and then you can define time it decorator above it. So similarly, we are going to use the decorator. Okay. And for that, we will import this function. These are the functions we have used before. But this particular one is something that we will use to define this decorator. So we'll say at dp.materializedView. And here you are going to define that materialized view. All right. So you will say name is whatever. Then you will supply other arguments. So let me just copy paste it here. So you will say comment city data row processing, okay? And the name, I'm going to call it transportation.bronze.city. Essentially, we have the catalog called transportation, where we have bronze layer, which is a schema, and city will be a table in it, okay? So by default, what SDP will do is it will look at a function which has this decorator and it will simply execute that function. So when it executes it, it will get the data from S3 into this data frame. It will add these two metadata columns. And then this data frame, it will store it as this table, transportation.bronze.city. It will insert into that table and the parameters it will apply are these. Okay, so it will have change data feed enable. Once again, if you don't know what is CDF, etc., refer to my other Databricks video, the complete crash course on Databricks. I have explained all these concepts there. Okay, so I think this is it. Now you compare this particular code with this code, right? It is much shorter. I know we are not doing too much here. It's a simple code, but when you have a complex code where you are doing a lot of things, at that time Lakeflow Spark Declarative Pipelines will save you a lot of time. It will create a robust data pipeline which will not be prone to errors, etc. Okay, so let's click on dry run, and dry run, what it does is it will just make sure that structure wise logically your pipeline is good. Okay, so let's click on dry run right now. It is complete now and it created this kind of graph. So if you click on maximized, see, this is the pipeline graph. Right now I have only one step, which is creating materialized view of the city. Now the other value for this can be a streaming table. Streaming table is something that we use in our fact data. For our dimension data, we will use materialized view. Now, materialized view in a traditional database sense is, see, a view in a traditional database is just a virtual thing. It will run a query every time you access the data in that view, and on fly, it will build that view. But materialized view is something where it will cache the data to disk. You know, it will persist it to the disk. So that is in a traditional database sense. Here, it is essentially creating a new delta table called transportation.bronze.city and storing that data. And for dimension table, which is city is a dimension table here, we will use materialized view. And for fact tables, we will use streaming table. Now, folks, if I go to my catalog right now, click on transportation, bronze, I don't see a table because we have done only dry run. Now I would like to actually run it. Okay, so you can run it by clicking on this, or you can say run file. So let's click on it, and now it will run it. Running means it will now execute this code. Previously in a dry run, it was just validating the code. Now it is actually going to S3. Okay, it is adding these two columns and it is storing it into this particular table. So see here, if you look at it, it says output records 10, and you can also view this, see city, right? And you can view all those records here. You can see these two metadata columns. Okay, so that's what this bottom panel is doing. So you created this city. You can verify it in Catalog Explorer true. When I go to bronze, and here I will see my city. All right, so as you can see, I have all my records. Hooray, we just created the first portion in our declarative pipeline. As you can clearly see, the traditional code would have looked bigger, and it's overall SDP is a better approach because you are just specifying what to do and you don't bother about how to do it. Of course, transformation is something that is business specific, so Databricks wouldn't know what kind of transformation you want to apply. Therefore, they provide this function where you can apply your transformation. But other than that, you just use this decorator and your work will be done. After bronze processing, let's do processing in a silver layer. So here I will create a new file and call it city.py. Okay. And in this file, I will write similar kind of code. Okay, so I will create a function first of all, and that function will simply read the data from bronze table. Okay, so this is my bronze table, and I'm creating a data frame by calling spark.read.table. And this particular table, the bronze table, has a column called ingest datetime. I will rename that to bronze ingest timestamp because the timestamp for silver will be different. So I need to add a separate timestamp column for silver processing. And by the way, I'm seeing all these errors. So let me import the necessary libraries here. All right. So now this looks good. And you can rename these columns to whatever. Sometimes people have different names of column in different layers. So you can do that using alias. So here, only one column name that I'm changing is ingest datetime. Because if I have ingest datetime in city silver, that will be confusing because this one is the ingest timestamp for bronze. Okay. And for silver processing time, I will create a new column called silver processed timestamp. Okay. And then you will just return df silver. Once again, I need to add a decorator called materialized view here. And what will be the name, by the way? Well, name will be exactly transportation.silver.city. That is the name. And then you can have comment and some table properties. Okay, I'm enabling change data feed, quality layer, and so on. Okay, now let's, as usual, let's do a dry run first. And by the way, I want to show you if I have any problem, what happens. See, let me just Control X. Let me just remove the decorator. Okay, and let me just do a dry run. See, this run completed, but I don't think it will do anything. It will not ingest the data into this particular, the new materialized view that I have, right? So therefore, I need to specify it here. Let me just, let's assume you have some kind of programming error. For example, I have this error, like indentation problem. I mean, the IDE, the editor itself is showing you that problem. But when you do dry run, see, at that time, it will give you this error. I hope you understand the purpose of dry run. It is just to flag any issues. It's just a mechanism of doing a validation. Okay, so let's fix all the errors. So this looks good. And now let's do a dry run. I think this is running. Okay, I clicked on run pipeline. So this is running directly. As you can see, it first ran this. We didn't have to run the entire pipeline. We could have done this run file, in which case it will run just this silver processing. But anyways, we ran the entire pipeline. And if you look at it, what happened is, you see this green check mark, both of it worked okay. This one is bronze layer, this one is the silver layer. You can go to catalog and click on silver. And now in the silver layer, you will see this city table. See? So you have bronze timestamp and you have silver timestamp. You probably noticed this, that it is building this dependency graph, okay, like this kind of arrow, based on the code that we have written so far. In this code, we are saying that my source table is this bronze.city and I'm writing my data to silver.city. So it will detect all of that and it will create this particular graph on fly when you run your pipeline. Let's go over some of the key concepts and let's understand some of the theory. So Lakeflow Spark Declarative Pipeline is a declarative framework for developing and running batch and streaming data pipelines in SQL and Python. We already used Python for our city table. Okay, so we understood the difference between imperative and declarative programming, and Lakeflow SDP supports declarative paradigm. Basically, it's a declarative framework where you can build either batch or a streaming data pipelines using Python or SQL. Let's go over some of the key concepts. The first one is a flow. So in our case, what we did is we had this transformation logic, right, which we defined using this function. And then we had a materialized view, which was our transportation.bronze.city. So we were reading data from S3, right? So see this source path S3 is something that we referred here. That was our source. Then we added these two columns, right? So that is, we can say it's a transformation logic. And eventually we wrote data to a materialized view using this particular annotation. So here the transformation logic is nothing but a flow. Okay, so this thing right here is your flow. It's a fundamental unit of work that defines how data moves from source to a destination. Okay, now there are different types of flows supported in SDP. Materialized view, this is something that we already looked at it. Then there is append flow, auto CDC flow. CDC means change data capture, etc. Materialized view flow is used for batch processing, whereas append and auto CDC is used for stream processing. So this is the example of the materialized view flow. You will use this particular decorator at dp.materializedView for this particular flow, where your destination will be a materialized view. For append flow, it is mainly used for streaming use case. It's a streaming flow for streaming tables, and it is insert only. It never updates existing rows. Now it is best for raw logs, click streams, IoT events, etc. When you're having too many like logs, let's say application logs, it's okay, even if you are writing duplicates, etc. So that way you get the speed. Okay, and this append flow is based for all these use cases. Then there is auto CDC. So this flow supports inserts, updates, and deletes, and it is available only in Lakeflow SDP. Now there is plain Apache Spark Declarative Pipeline. Here, this auto CDC flow is not available. So this is the benefit of using Databricks, where you are using Lakeflow SDP and you get this support for auto CDC. It will support both slowly changing dimension. Okay, SCD means slowly changing dimension, type 1 and type 2. It supports both of them. Materialized view is already something we saw. So when we wrote that city table, if you go to catalog and hover your mouse cursor over, you will see this tooltip. It will say materialized view. You can also go to details and check the type. So see, here the type is materialized view. So it is essentially a form of Unity catalog managed table, and it's a batch target. Okay, so it's basically a managed table supported by Unity catalog, and it can have one or more materialized view flows written into it. So whenever you have materialized view, a materialized view flow will write to it. And it differs from streaming tables actually, in that you always define the flows implicitly as a part of the view definition itself. And that is what we did in the case of city dimension table. Then there is streaming tables. So streaming table is a form of Unity catalog managed table that is also a streaming target for Lakeflow SDP. Okay, and it is used for streaming use cases. It can have one or more streaming flows written into it, either append or auto CDC. Then there is sync. So sync is a simple concept. It's nothing but a streaming target for a pipeline and supports delta table. So as a sync, let's say you have a streaming flow. In that, your target, your destination can be a delta table, Apache Kafka topic, Azure Event Hubs topics, custom Python data sources, etc. And all of them, are commonly called a sync. And it can have one or more streaming flows written into it. Then there is pipeline. Data pipeline is a common concept that we all know. Essentially, you have raw data and business data as your destination, and whatever you do in between is can be done through a pipeline. Okay, so usually what do? We have bronze, silver, gold layer transformation. Okay, so this is your pipeline. Data flows through it and it gets enriched. You clean data, you create business ready columns, and so on. This whole thing is your pipeline. It's a unit of development and execution in Lakeflow Spark Declarative Pipeline. See, data pipeline is a common term, but in this context, when you're talking about Lakeflow Spark Declarative Pipeline, a pipeline is a unit of development and execution. Now you can run this pipeline on some schedule. So we'll look into it. We'll go to the pipeline and we can schedule it. It can also run automatically. Let's say when new data arrives, the pipeline is active and data will flow through the pipeline. It can contain one or more flows, streaming tables, materialized views, and syncs. Okay, so you can have append flow, auto CDC flow, etc. You can have streaming tables, materialized views, syncs, etc. And this is a nice diagram which captures the essence of all those concepts. See, whatever we did for our city dimension table is this particular use case. Okay, the second one. So your batch source was S3 table, S3 bucket, basically ct.csv. Then we wrote that Python function, which was a materialized view flow, and the data went into the materialized view, which was our city table. Streaming use case is something that we'll cover later on. Here you can have append flow or auto CDC flow, and you can have a sync or a streaming table as your stream target. Let us pause for a moment and think about our next step. We have two tables, city and trips. City is a dimension table, trips is a fact table. When you're doing any analysis, let's say you're building any BI dashboard, etc., most of the time you need additional dimension table called calendar or a date table. So let's say if you want to do analysis on your trips, aggregated based on quarters or based on, let's say, weekday versus weekend, or let's say monthly, etc. In that case, this calendar or a date table will be pretty useful. And we have used this date table in many of our videos on our channel. Okay, if you look at even our past 2 Databricks video, you will find that we always have calendar or date as one of the dimension table. And this table is something you can generate programmatically. Okay, so let's say if you write this kind of SQL query, okay, select, explode this and this, then you get all the days between, let's say, 1st Jan and 1st February, right? So similarly, we will use this SQL query in our Python code, in our declarative pipeline, to generate the dates, let's say between 1st Jan to 31st December, okay, the entire year. And then we will add additional columns via code. We will say, okay, is this a weekday or weekend? We will also extract month, quarter, and so on. Okay, all of this can be done programmatically using our Python code. So let's go ahead and in our silver table, see this date table we are creating as an additional table. So it will go in silver, not in bronze, because bronze is all the raw data that you're getting from S3. Okay, so here I will create a new file called calendar.py. Okay, so let's create this. Let's import some of the important libraries. Okay, and start date and end date is something that we want to receive it via some kind of configuration. So here you can say spark.conf.get to get this from configuration. I will show you how to set up this configuration later on. Okay, and then we can have this function. Okay, so let's define this function calendar. Okay, so it's the same query that we ran here, and that will give you all the dates between start date and end date, and it will put it in a data frame. After that, you can have bunch of transformation, right? You can have things such as, you can first generate a date key, and it is nothing but, see, you are creating one column called date, and based on that you are deriving all this information. See, you created this as date column, which is this. Now once you have this kind of date, you can create a date key, which is the same date. Essentially you are removing this hyphen. Okay, so that will be the key for the table. Then you can have a year column, which will be nothing but year extracted from the same date column, month, quarter, and so on, right? So you're creating all these columns, and you are doing also a bunch of other transformation. So I'm going to give you this code, folks. Just copy paste. We don't need to write all of it. It's pretty straightforward. We have covered this kind of code in many of our past videos. So here, see, you are getting day of the month, day of week, all of that, right? Month name, Jan, February, etc. Quarter, week, is weekend, is weekday, holiday. You're defining some of the holiday, right? Like these are like all Indian holidays and so on. And eventually you will get a table which will have all these columns. Okay, so this is your transformation function, but we need to define the annotation as well, right? So let's add the decorator. So this is a materialized view, and it will store it in transportation.silver.calendar table. So that view will appear in the silver schema. And these are the table properties. Okay, these are the same ones that I think we used it for the city table. All right, so this looks good to me, and I would like to do a dry run here. So my dry run failed, and the error I'm getting is SQL config start date cannot be found. So see, this is the benefit of doing dry run. If there are any logical errors, configuration missing, etc., it will point it. Okay, so when I say spark.conf.get start date, from where exactly it gets that configuration, we have to define that configuration parameter, and you can go to settings and do that. Okay, so click on this cogwheel and scroll down, and here you see this configuration. So let's add configuration start date, which is 1st Jan 2025, and then end date is going to be 31st December 2025. Okay, so let's hit save. So now you see in the configuration you see start date and end date. So let's close this and let's do a dry run again. So this time the dry run finished successfully without any issues. Okay, and you're seeing this calendar table here. Now let's run this. So you can run this file or you can run the pipeline. This will run everything. We don't need to run the entire pipeline. So I will just click on run file, and get my materialized view created for calendar table. After a few seconds, it completed successfully. You see this green arrow. By the way, you can click on maximized and see your entire pipeline. Okay, so we had city bronze processing, city silver processing, and we have calendar silver processing. This is independent, right? This is not connected with these two. So that's why it is not showing any link between these. Okay. And here, if you click on this calendar, it will show you all this. Okay. We can also check this in our catalog. So let's go to catalog, hit refresh, and in silver, you will see this calendar table. So as you can see in this calendar table, you have date column, then date key, year, month, day of week. See how amazing it is. Now, if you want to do your trip analytics, let's say for January month, what you can do is you can join your fact table with this date or calendar table, and whatever visualization you're using, Power BI, Click, etc. You can, plot nice visuals, which will show you the data based on the time dimension. You can also use this date table for your AI needs. Okay, it can be used for both AI as well as your BI needs. See here, also in catalog view, you can see that this table is created. And once again, this is a materialized view. Let's now process our fact table. We have one fact table which is called trips. And we have a trips data per day. So this is the data for 1st August. And the columns we have is trip ID, date, city ID, passenger type, whether it's new or repeated, distance traveled, passenger rating and driver rating, etc. I will go here and create a new file in bronze, and let's call it trips. Okay, so trips.py, and let's open that file. Okay, so this is the trips.py file, and first of all, let me import the necessary libraries. Okay, so this is going to be dp1, and I will write a function to read trips data from S3. And here notice one thing, we are using read stream. Read stream will read the data in a streaming fashion, and the benefit of doing this is going to be that whenever new file is dropped, right? See, in fact, data changes often. So this is my bucket. Okay, and daily a new file gets dropped. So once I'm done processing all the files, and let's say my pipeline is running on day-to-day basis, okay, and let's say next day completes, at that time when it drops the new file, because of this code, it will only process the new file. It will not process all the other existing files. So this is called an autoloader feature in Databricks. And the way you get it is by using read stream function with this cloud files argument. Okay, so this is autoloader. If you want to learn more about autoloader, you can Google it, you can ask ChatGPT, and it will tell you more. But the crux of this feature is that you have, let's say, 100 files and you have processed all of them. On the next day, when 101 file gets dropped in that folder, through this feature, you are only going to process the new file. Okay, you can ignore the rest of the old files which are processed. Schema evolution mode rescue will make sure that if, let's say, there is schema changes, then this will not fail. It will create a new rescue column. So I will show you that column once this is done. And then infer column types means based on the data, infer the column type, whether it's integer, string, etc. And max files per trigger means when you drop the new files, let's say if one file gets dropped, it will be processed. But let's say if you drop 105 files, then 100 file gets processed in one batch, like one trigger, and the remaining 5 files will be processed in the other batch. So this is stream processing, but underneath per trigger, it will use this batch of files for doing the processing. And then we have this column called distance traveled kilometer. Okay, so let me just show you. You see this, and this bracket will create issues for us. So therefore, we have renamed it to _km. If you want, you can do a dry run. Okay, let me stop it. By mistake, I clicked on run pipeline. But if you do a dry run, you will notice a problem if you don't have this particular line. Okay, you can try it out. Okay, I tried it. I was getting error, and that is the reason I put this code in. And then we will also have the metadata columns, right? Like the file name, the ingest date time, and so on. Okay, so this code looks pretty straightforward. Just to summarize, you are doing stream processing and you are using autoloader feature to process only the new files. Let's say if you're not using autoloader, then what you will do is once you process all these files, you will create a directory called processed, and you have to move those files into process directory. So when new file comes in a parent directory, it can process only the new files. Okay, and that approach is manual. When I was at Bloomberg, we used to use this approach. We were not using Databricks in my job, so we were manually processing the files and moving it to processed folder. If let's say some of the files get failed, then there will be a failed folder. Okay, so there is process folder, failed folder, and there will be files which are unprocessed. But using autoloader feature, you don't have to do all of that. Okay, so it saves you a lot of time from writing all that code. And then here, see, previously we were using @dp materialize view, right? But here we are going to use .table. Okay, so this .table will create a streaming table, and the arguments I will supply are these. So you are creating a streaming table in transportation.bronze schema. Okay, and the table name is trips. This is the comment, and these are the arguments. These arguments are similar to what we have seen before. Now you can refer to the documentation if you want to learn more. Okay, so here, see, this table will create the streaming table. See, streaming read on table. This is the syntax essentially. @db.table, then you have function name, and then read stream.table, or if you're using autoloader, read stream.format, right? So this is the syntax that we are using. Make sure you are changing this bucket to the bucket that you have. Now you can do a dry run. I don't want to do that. I will just directly run this file. So my run is completed. You can see the check mark here, and you can see that it inserted 356,000 rows, folks. We had that much data. If you look at this particular bucket, see, we have data for all these months, I think August to December. Okay, and each of these CSV file will have some records. So if you sum it up all together, you get 356,000 records. And you can see that it is building this pipeline. See, these two have dependency, but these are running separately. You can also go here, refresh, go to bronze. You will see trips. Now see, trips, it says streaming table. Okay, so if you go here, and if you click on the details, it is streaming table. So it is a managed table, which is managed by Unity Catalog, but the type of this table is streaming table, whereas the type of the city table, if you see here, it is materialized view. In the sample data, I can see all these records, see, trip ID, date, and so on, and you will see this column rescued data. Remember I told you about this particular argument. So this rescued data will contain data whenever there is an error. Okay, it will not throw that record. It will show that record here, and in the individual column it will show null. Folks, I recommend that you use AI to understand this code as well. So what you can do is copy paste this code in ChatGPT and just say, hey ChatGPT, explain this code, and it will explain you the purpose of each of these arguments, each of these instructions, etc. Using AI to understand the code, to write code, is going to be a very important skill in this new AI era. Okay, so don't get stuck, folks. Anytime you are confused about any parameter, you have AI. AI can explain you really well. Let's move to the next step, which is creating the Silver processing for trips. So I'll go to Silver and create a new file called trips.py. Okay, so here is the file. Let us import necessary libraries and then define a function which will read our bronze table. Okay, so I'm reading bronze table here, and when you do read stream, it will only read the updated records because change data feed is enabled in this bronze function, right? So if you look at the bronze layer processing, when we created this table, we enabled change data processing. Due to that, when I call read stream function on that table, it will only read the updated rows, because see, bronze is just accumulating all the rows. You don't want to process the rows which are already previously processed. So you should update only, or you should rather process only the updated rows. Okay. And then we can probably change names of certain columns. Let's say for our business needs, I want fair amount to be called sales amount. See, this will happen. Your column names will not be perfect, and as you process them through bronze, silver, gold, you may want to change the names. And you will also take care of your timestamp. So here, silver process timestamp will be the current timestamp, and the previous timestamp which we had, which was ingest timestamp, is actually bronze ingest timestamp. Okay. Now, folks, we are not doing many transformations here because the entire purpose of this tutorial is to teach you the Lakeflow Spark Declarative Pipelines. So we are focusing more on that. But in real life, you can do n number of transformations here. All right, let's return the silver data frame. Okay. Now here, what I will do is I will create a view. Okay. I will create a view, and let's call it a staging view. Okay. So why we are doing that? Well, please hold on. I will explain. So we are going to use this auto CDC flow and creating staging view, which is like a intermediate temporary view where you're doing all the processing, is going to help us with many things. So I will explain why it is needed, but let's create it for now. And I will put some additional annotations called expect. Okay. So this is a validation basically. You are validating that your business date year is greater than 2020. We are processing data more than 2020. If it is less than 2020, then it will not stop the processing, but it will log the error. And that error we can look through the UI, or we can run some SQL query and we can get an idea on the failures. Okay. So if you read the documentation for expectation, they have these different modes. So we are using expect here, which means track the error, but it will continue the processing. If you expect or drop, it will track the error, but the record which has an error, it will drop it. If you use expect or fail, in that case, the moment it encounters the error, it will fail the pipeline. So based on the use case that you have, you can use one or the other. In our case, if there is one record which is invalid, we don't want to stop the processing of the pipeline. So we are using expect, and if the error occurs, it will just log it, which we can view through UI or through a SQL query. Okay. So we are checking the driver rating is between 1 to 10. Passenger rating is between 1 to 10 because that's a valid range. Due to whatever error, if it is out of the range, then we will track that error. Okay. So I hope this much is clear. All right. So just to summarize, what we are doing is from bronze table, we are reading only updated records. We are just changing names of certain columns. You can do n number of transformations, and that you are storing in a view, which is your staging table. Okay. Now let's create our actual silver table, and it's a streaming table. So you will say dp.create streaming table transportation.silver.trips. Okay. This is the comment and the properties. So here also we have enabled the change data feed. The comment is cleaned and validated orders with CDC upsert capability. CDC means change data capture. Change data capture is an important term in data engineering. Whenever data is changing, you want to capture only the rows which are updated, either updated or deleted or added. Okay. So that is basically your CDC. You have created this streaming table. Now the next step will be to let your data flow from silver staging to this table. Okay, and that you can do using the auto CDC flow. So this is how you do it. You will create auto CDC flow. Your target is your silver table. Source is this silver staging. Remember this silver staging table, and keys is ID. So ID is nothing but a trip ID. See, we have just renamed it. So what it will do is, in the target table, if there is a record with the same trip ID, it will update it. And if there is no record, it will insert it. Remember that upsert behavior. If you have seen my previous Databricks video, we do the upsert operation, which is if the ID is present in the database, then update that record, overwrite that record. If it is not present, then insert it. If you're writing the code, you have to do like, when match ID, then update, otherwise insert. You have to write all that code. But using Spark Declarative Pipeline, it becomes very easy. See, in just one line, now you can say, okay, this is my key. And by the way, this is an array. So you can have multiple fields also. Okay. So this is my primary key. For this, if you find a record in this particular table, then update. If you don't find it, then insert. Okay. It tackles the other issue as well, which is out of sequence. Sometimes the records are out of sequence and you want them to be sequenced by this silver processing timestamp. The next argument is slowly changing dimension, SCD type 1, which means if you find a record with the same trip ID, then overwrite it. See, if I do SCD type 2, what it will do is it will insert a new record with start and end date. This is valid for cases like customer. Okay, let's say you have a customer record and customer changes their email ID or address. In that case, you are not deleting the customer record, or you don't update the same customer record and overwrite your address, right? Overwrite customer's address. You will have second record which will say, okay, customer address is valid from this date to the other date. Okay, and the previous record will also have a start date and end date. So if you do 2, it will do the slowly changing dimension type 2. Here for trip ID, we can just overwrite the record. So that's why we are supplying this as 1. Now folks, let me show you how the procedural code will look like. See, here we wrote only these many lines, right? Like 50 lines. Now, let me go to ChatGPT and say that below is the code from Spark Declarative Pipeline. Generate traditional code, which is not basically non-declarative code. It is also called imperative. Generate imperative equivalent. So, see, you can use declarative programming or imperative, up to you. But declarative programming will bring the benefit, which is it will reduce the size of the code, first of all. And you don't have to do manual stitching, orchestration, all of that. Okay. You just specify what you want to do. You don't have to worry about how you want to do it. So see, imperative equivalent will be this. So here you are creating a table, if not exist, right? You're creating equivalent of create streaming table. Then you are setting the table properties. Then you read your bronze table. Then you create your silver staging. Okay. You run your validation and then upsert SCD. See, you're doing upsert SCD. Okay. Remember this code from other Databricks tutorial, when not match insert, when match update. You have to do all of that. Okay. Now see, if I copy this code into my notepad and if I count the lines, it's 135 lines. Whereas here it is only 50 lines. And when you write less code using declarative pipeline, it is less error prone, right? The probability of making error in a bigger code base is higher, usually, not all the time, than probability of you making the error in a small code base. Okay, so you now understand the benefit of this declarative pipeline. All right. I think we are done with this. You can do dry run, but I'm going to run this directly. So let's click on run file. Right now it is just preparing a graph. See, preparing a new graph is going to take a couple of minutes. And this one is the bronze table. You will see the new pipeline appearing here after this point. You see? Now it appeared. So you created this view and you see like the stream is flowing into a streaming table. The view is created, and from view you are streaming your data into your Silver streaming table. See, run completed and 356k records were updated. This table we are creating for the first time. But when you do incremental data updates, you will see that it will only observe the new records. It will not touch the old records. Okay, so let's verify it in our catalog. So I'm just hitting refresh icon here. And let's go here. See, now you are seeing this trips table, and you can view the data here also. I think tables, I think this one, right? So if you click on this, here you are seeing the data. See, you have trip ID, business date, city ID. You will see all the renamed columns, right? This was like fair amount or something. We changed it to sales amount. See. Let me just show you. This was, see, it's changed from this to sales amount. So all transformations are working okay. And you have bronze ingest timestamp as well as silver process timestamp. And you can see this here also, see in the catalog view. All right. So we are done processing our fact table in Silver layer. Folks, it is now time to do our gold processing. So far, we have city and calendar as our dimension table. Okay, so these two are in Silver layer. These two are dimension table, and trips is our fact table. In gold layer, we will simply join these three. Okay, and we will generate a highly denormalized table which will have all the columns from all these tables. Okay, so this is one big table which will contain all the data, and we have these regional managers who cares about the statistics for their own city. So see, we have our business Good Caps is operating in all these cities. These are cities in India, by the way, and we have separate regional manager per city. So let's say for Surat, the person can be Mohan. Okay, for Indore it can be Meera. Okay, Visakhapatnam, it can be Fatima. And Meera doesn't care what's going on in Surat or Lucknow. She cares only about Indore. Okay, so what we will do is we'll create city specific view as well. Okay, so here, once you have the data from all the cities, we are going to generate city specific view. So there will be one view for, let's say, Indore. There will be another view for, let's say, Surat. Okay, another view for Vadodara, and so on. So this way, the individual regional managers can hook their BI dashboard with these views. Okay, so there can be a BI dashboard which is hooked to this view, and this BI dashboard will show all the visuals and charts and things like that. Okay, and the manager for Indore will be using this. Manager for Surat will be using, maybe they have different dashboard. Okay, so we can get all that flexibility. So I hope you are getting the idea on what we are going to do in this section, which is we will combine all of this to a single view called trips, right? Gold trips, something like that. And then we will create individual views per city. So let's go to our gold folder, and here we are going to create a file. Now this time we are going to use SQL, by the way. We'll not use Python. Okay, and let's call this one trips underscore gold. So trips underscore gold dot SQL, and you can use AI as well. You can just say generate with AI, and you can say, okay, generate this common view. I already have that SQL with me, so I'm just going to copy paste. So see, I'm creating a view called gold fact trips, where I'm doing a join between these three tables. Okay, so I'm joining trips, city, calendar, and pulling majority of the fields. Okay, so from trips I am pulling ID, business date, etc. From city I am pulling city name. From calendar I am pulling month, quarter, things like that. So let's do a dry run. I will click here, click on a dry run, and let me just maximize this view here. Wonderful. So this is how my pipeline is going to look like. So I'm joining calendar, city, trips, and I will get fact trips. Okay, and this is the previous pipeline if you remember. So city from bronze to city silver. Okay, you see silver in the tooltip. Here in the tooltip you will see bronze. Then here we have trips, which is bronze, then temporary staging view, and then you have trips, which is silver, and we are joining here. Okay, all right. Now instead of running this, let me just create the city specific views as well. It's pretty straightforward. So let's create a new file, SQL, and this file is for Vadodara. Okay, so trips Vadodara. And see, if you know the basics of SQL, this should be pretty easy actually. You will create a view. Okay, so see, from fact trips you are creating a view where city ID is GJ02. So if you look at this, see, Vadodara city ID is GJ02. And similarly, you can create views for all other cities. Just to save the time, I am going to simply drag and drop those views. Okay, so I only have those SQL files with me. Okay, so here, the way you import those files is go to gold and click on import. And then here we have all the files. I unselected trips gold and trips Vadodara because we have it already. We are going to give you all the code. Check the video description, folks. So let's drag and drop this here. Okay, import. And see, all of these things are imported. Now we are ready to run our pipeline. So just click on run pipeline and maximize the view. By the way, if you want to see the execution, see, you see here, it will show you all the runs. So you can click on this as well. Okay, so if you click on this, it will open the monitoring page and you will be able to see the details of your pipeline. Okay, so see, it started running it. You can see it here as well. You can see some spinning wheel. See, here is spinning wheel. Let's just make it bigger. So you can see it finished this. It actually finished the entire thing. Okay. Now it automatically detects the dependencies, because when I'm creating fact trips Kochi, I know that I'm using fact trips as my source table. So this graph, the pipeline graph, it will create automatically. And this is how my entire pipeline looks right now. So let's go to catalog and let's make sure we have the data. See, these are all views, by the way. See, we have fact trips, Chandigarh, everything. See, like, let's click on this. See, here you will see data from all the cities. Okay, right now it's showing only Chandigarh, but this table contains all the data. And if you want to see data for, let's say, Vadodara, you click on it, go to sample data, and here you see data for only Vadodara. And now the regional managers are going to use these views to build their dashboards, or let's say if they want to build AI solution, they can use this data. Okay, so our data engineering pipeline is kind of complete, and you have the good quality data, good quality massage data that can be used both for BI as well as for AI needs. And here, by the way, I like this feature from Databricks. This is Gini. So let's say I want to know which day of the week has highest passenger rating, right? So I can click on it. And this is only for Vadodara, by the way. So let's say I'm regional manager in Vadodara. I want to know the answer. You can run this query and it will show me the rating. See, Thursday. Okay, on Thursday I'm getting the highest rating. Okay, so we can ask different questions. I would suggest you ask different questions on this, right? Which month has the highest? You can say, okay, what is the average driver rating? Okay, and it will generate the query. You can run the query. And this is, by the way, only for Vadodara. So in Vadodara, the average driver rating is 6.65. Now, if I go to my trips, this is the entire table, right? So here I can say, what is the average driver rating by city? and it will tell me that. See, isn't this amazing? This is so quick. You build your pipeline, and right here in the same platform, you can do your analytics using this Genie. And this is called unified analytics, folks. Here in a single platform, which is Databricks, you are able to do your data engineering, data analysis, data science, all in one place. Folks, let's now discuss incremental load. So far what we have done is we have done a full load where we uploaded data all the way till 26 December. See, 26 December. And you can see that here in S3 also. Okay, and you can verify it, by the way, in your catalog. So let's go here. And you can say, see, in fact trips, you can say what is the max date. If your server has stopped, it will not run your query. So I clicked here in this location and I made it up. So now it is saying max date is 26. Okay. So this part looks good. Now, here's my pipeline. How do you exactly schedule these pipelines? There are two ways. You can click on schedule icon and you can schedule it for a specific time. So usually people, what they do is they run it once a day or multiple times a day. And you can say, okay, run this at 11 o'clock or let's say 11 o'clock in night, okay, which is 23. Let's say 11:30. I want to run it at 11:30 where my business is closed every day. And you can use cron syntax as well. But what we are going to do is not use a fixed schedule. Instead, as soon as the file is dropped here in my S3, I want this pipeline to run. So for that, you will click on this cogwheel and you will change this mode. See, right now pipeline mode is triggered, which means when you manually trigger it, it will run it at that time. But we will make it continuous. So hit continuous, save, and close it. Now see, it is preparing the pipeline to run it in a continuous mode. And you can check the progress by right clicking on this bar. Okay. And you can go to this page. See. So let's wait until this pipeline is initialized and it is in a continuous running mode. Okay. My pipeline is now running. Okay. You can also go to this page and see it. See, you see this thing is kind of running now. Let me close this one so that I can see it in a maximize mode. Okay, you can view it from here also. So let's fit to the view and let's close this. Okay, let's just view it here. Okay. So what you see here is the pipeline is running. Now the materialized view, see, they are static. So there is no change to it. You see this activity only in streaming tables. And that's kind of explains the entire purpose of streaming table, which is to detect the change in data and process it. Okay. All right. Now let's go to our S3 and here click on upload and I will upload the file for 27. If you look at that file, here is the file for 27 December. It has around 1.8K records. Okay, so let's drag and drop. So I'm going to drag and drop the 27 file and hit upload. So it is uploading. Now notice this. Now see, this pipeline is running. So it will detect that new file has arrived in S3 and it will process it. You see 1.8K records. 1.8K records. Now it will come here. Okay. So let's see. See that S3 changed. That's why it is processing this as well, because there was an update in bucket. See, 1.8K. Isn't this amazing, folks? And for the trips, the view of trips is static because it's a view. See, this is a view, whereas this is a streaming table. Okay. Now let's go to here and let's verify. Okay. So I'm going to say what is my maximum date and run the query. Sometimes see there is a delay, so you may not get this right away. You might have to wait. Let me just refresh this real quick. Let me ask this question again. Okay, reset. What is the max state? Run query 27. Isn't this amazing? The pipeline is running continuously and it is processing those records. So as an exercise, I want you to drop all these files one by one and just monitor, how pipeline is processing it and how it shows the data eventually in your fact table. All right, folks. So that's it, folks. We are done with this incremental processing. Just to summarize, what we did is we changed the mode of our pipeline to continuous and we dropped the new file in S3. We saw how it is processing it. Okay. Just to save the resources, you can stop it. It's important you stop it. If you leave it, it will keep on running. Okay. And you have some free credits, so it may exhaust your credits. So I'm going to stop it right now. We have created all these views. The next step will be to enable access of regional managers to the corresponding views. And this access management is an important part of data governance. So let's say you have this fact trips Vadodara, and let's say the person who is managing that person's name is, let's say, Keshav. Okay, so Keshav is a person who is managing this and you want to give them an access of this. So what you will do is you will go here and click on settings. So here you will go to identity and access and click on manage, and here you can add users. So I have this different account with this ID called double.codebasics.test@gmail. And let's say this person, let's assume is a Kesav, and Kesav is the regional manager for Vadodara. So now what you will do is, I think you should click on add new and add that person or that user ID here. Okay. So see, this test is added here. Now you will go to the catalog and click on the corresponding view, which is fact trips Vadodara. Go to permissions, and here you can grant the access. Right now, to make things simple, we are granting access to a user. Usually, see, in a sophisticated environment, most of the companies, what they will do is they will use role-based access control, RBAC, where they will add user to a group. Okay, so let me just show you that. So see, here you have users. So in user, you added this test@gmail.com, right? And test3 is my current account. Now I will create a group, and group will be, let's say, Vadodara team. Okay, actually, let me go here. Yeah, Vadodara team. That is a group. Okay, and in that group, you will add that particular user. So if I click on this, I can add members, and in here I can add this particular person. Okay, so now let's go to the catalog, and in catalog we will go to transportation, gold, Vadodara, go to permissions, grant, and here you will say Vadodara team, right? So instead of granting access to individual, you are granting access to a team or to a role. So let's say if Keshav joins different team, let's say they join Mumbai team tomorrow. In that case, you don't have to change anything because they'll be removed from Vadodara group. They'll be added to Mumbai team. But whoever is in Vadodara team will always have the access. So this is called role-based access control. And in the privileges, let me just grant all privileges. Okay, so hit confirm. So now see, this particular user has this access. Okay, now I will get this email, okay, to join. So I can click on join now, and that way Okay, let's hit continue with Google, click on workspace. Okay, so that way I have joined that particular group. Now for that user, I see transportation schema. And see, I don't see bronze and silver because I have given access to only gold, and that to Fact Trips Vadodara. See, now I am able to access it. I can look at the records, and the Vadodara regional manager will be able to build dashboards, or they will be able to perform the analytics using this Genie, using this AI. So this access control is an important aspect of data governance, and usually it is done through role-based access control. I have just shown you the scenario for Vadodara, but similarly, you will have teams for different cities, and you can enable those groups for a corresponding views. We are done with the project implementation. Just to summarize, what we did is we had all our data in S3 using Lakeflow Spark Declarative Pipelines. We ingested that data into bronze. Okay. Then from bronze, we transformed it into silver and then gold. Okay. So we used this declarative pipelines. We used Unity Catalog for the access management. And then we did some quick analytics using Genie. Remember, we used to type natural queries in Databricks, and it will transform that into SQL queries. So that's your AI feature. They have a separate Genie option also. So it's kind of related AI features. We didn't build a dashboard, but that was not the purpose of this video. Okay, so we are done with this project, and now let's summarize the benefits of Lakeflow Spark Declarative Pipelines. So the first benefit is obvious one, declarative processing, where you focus on what to do rather than how to do. As a result, you can write much less code. We already saw in the case of trips when we are doing silver processing, using declarative pipeline, it was 50 lines of code. If you use normal procedural code, remember we talked about this, it was 135 lines. Whereas the declarative pipeline code was only 50 lines. See, it was only 50 lines versus 135. So less code means you can focus on your business logic, and you don't have to worry about stitching the workflows, etc. Auto CDC, Auto Change Data Capture API, simplifies CDC processing. Once again, when we have this normal procedural imperative code, see, for CDC, you have to do all this logic, when not match, when match update, and so on. Whereas when you are using declarative flow, all you do is specify your key and just create auto CDC flow, and that's it. The next point is no need for manual code to handle out of order events. The second benefit is automatic orchestration. We saw that as you write declarative code, it will create the pipeline on its own. We don't have to stitch all these workflows. Okay, so that's a major benefit, and it also gives you efficient retry of transient failures. The third benefit is incremental processing. Okay, so you get incremental processing engine for materialized views, and it will reduce inefficient reprocessing of updates and new records.
All right, Peter, what have you got?
Well, Tony, overall, this was a good experiment. The main takeaway is we wrote much less code compared to our traditional pipelines.
Okay, that sounds interesting.
And instead of managing executions, dependencies, and stitching things together, we focused on business logic using this Lakeflow Spark Declarative Pipelines, and that made things simpler and less error prone.
Okay, but what is the benefit that you see from the business side?
From business side, it will help the most because the pipeline ran faster, incremental updates worked really well, and regional views were ready without reprocessing everything.
Okay, so I'm not sure if I'm asking this in the right way, but do you see this is fitting in our roadmap? What I mean to say is, like, do you see that we can replace all our old pipelines and use this method instead?
See, I wouldn't go that far. We just did one experiment and it looked good, but I'm not sure if this applies to every pipeline.
Okay, yeah. I mean, I mean, I wasn't expecting you to say yes to this anyway. I just wanted to know if there is a scope for that. But it's good because so these things, when it starts, it's good that we did an early experiment. So now that we can share this to Bruce, and then I hope you will be happy looking at something what we have done, because it has some concrete and tangible outcomes that we have got. And at the same time, we have done something new and experimental. So I think Bruce will appreciate this. Let's hear it from him.
Okay, I agree. Let's show it to Bruce. And I think it's worth sharing with the team and seeing where it fits going forward.
Great. Good job, Peter.
That's it, folks. I hope you enjoyed building this enterprise-grade Databricks project. If you want to get certified, visit our website. We are going to provide a link in the video description. Also, share your project on LinkedIn and tag Codebasics, Databricks, myself, and Hemanan. If you have any questions, there is a comment box below. Thank you for watching.